Okay, and we're on. Welcome back, everyone, to Grockit's OGTV. This is the GMAT edition, where we're going through the 12th edition of the official guide to the test, question by question, and from one purple cover to the other. And we are in the middle of the first third, maybe, of the section of problem-solving questions on page 157. My name is Jim Jacobson, and I will be going through these questions with you today. So 157, question number 34, like it says at the top of the screen. I took the liberty of actually putting that on the screen in advance of starting the broadcast this time, saving us a whole 25 seconds. Anyway, so without further ado, let's move on. So number 34, if Juan takes 11 seconds to run Y yards, how many seconds will it take him to run X yards at the same rate? So a formula that you absolutely need to be familiar with on the GMAT is the distance rate time thing. So distance equals the rate times the time. And whichever one of these three things you're solving for, you can simply divide, or treat it like an algebraic expression, because it is, and solve for the equation that you're after. So if we're trying to solve for time here, we would divide both sides by r. T equals distance divided by rate. So any time expression will be distance over rate. Any rate expression will be distance over time. Those are the three formulas, but they're really all the same one. So that's what you need to know. So in this case, we are given in the question Juan's rate. So his rate initially then is Y yards. Again, this is rate is distance over time over a period of 11 seconds. I have to spell the word seconds correctly. This is the GMAT. So, although obviously in real life I would probably just abbreviate it. And then we need to know how many seconds it will take him to run X yards at the same rate. So that's his new distance. So his distance of X yards, remember distance equals rate times time. So X yards is going to be, we'll call it S seconds, at the rate that he has already established, which is Y yards over a period of 11 seconds, which I am going to abbreviate this time. And this is the thing we're trying to solve for, is the number of seconds. We're trying to figure out the amount of time it's taking him to do this different distance. So just as when we were doing these other things before, here in this case we need to divide both sides by the rate to isolate the seconds on their own. So then that's X yards divided by this quantity. And you may remember, or actually that is perhaps a little bit less forceful than I should have been, you absolutely need to remember on the GMAT, when you divide by a fraction, that's the same thing, or the process of doing so is inverting the fraction and then multiplying. So this is the same thing as then multiplying X yards times 11 seconds over Y yards equals. So then that ends up being 11x over y equals the seconds. In this case, answer choice A is exactly that. So several of these other answers, this one in particular, choice E, is the trap. If you misidentify the rate formula as time over distance, that would give you this wrong answer here. And then these other ones are just various other misunderstandings about what exactly you're solving for, which variable represents which thing. But we didn't do that because we are onto this whole distance formula business. Choice A is the correct one. Why did I erase the page? We are on the same page. Well, if erasing something that you don't desperately need but didn't need to erase is the worst thing that happens to you on the GMAT, you are going to get a great score. So, still on page 157. But now we're on question 35. And we have some answers. That would be a rough GMAT with no answer choices. Okay. So John has 10 pairs of matched socks. If he loses 7 individual socks, what is the greatest number of pairs of matched socks he can have left? So, he starts out with 10 pairs. Minus 7 socks. So in order to have the most matching pairs left, we need to take as many whole pairs as possible. So, in other words, we want this to be as many pairs, the largest number of pairs left, and that means a lot of individual socks. So that, or no, excuse me, these need to be as many pairs as possible. So basically, we're dividing 7 divided by 2. So we can, when we divide 7 by 2, because there's 2 in a pair, we get 3 pairs and one remainder sock. So that's the largest number of pairs we can make out of the 7 socks that are missing. He probably lost them in the dryer. That's where I always lose mine, or under the bed. So, so if he lost 3 pairs and one remainder sock, that means he still has 6 pairs left, and plus one remainder sock. Because 3 pairs would be a total of 6 socks. So it'd be 3 pairs, but we can't count, so 10 minus 3 is 7, but he also lost another sock, so we're only counting his remaining matching pairs. So he has 6 full pairs and 1 half pair left. I guess that would have been another way that we could have looked at this, that he's losing, so 10 pairs minus 3.5 pairs equals 6.5 pairs left. And again, we're only counting the whole pairs that he has, so we only count the 6. Answer choice B. Do note that answer choice E is our trap. This is the answer if we tried to figure out what's the smallest number of pairs he could have left. In that case, we would want 7 individual socks. No pairs of socks at all disappear. So if he lost 7 individual socks, that means that he would only have 3 pairs left. So choice E is the answer to a question the GMAT wasn't asking. Choice B is the answer to the question it was asking. This time I will not erase the 157. I'm smart like that. Sometimes. Okay, on to number 36 in the second column. So what's the lowest positive integer that is divisible by each of the integers 1 through 7 inclusive? Integers 1 through 7 are 1, 2, 3, 4, 5, 6, 7. Do note that this would have been a different question if it had said the lowest positive integer that is divisible by each of the integers between 1 through 7. That would have excluded the 2 boundaries, because 1 is not between 1 and 7. 1 is one of the numbers 1 and 7. So the numbers between would have been these middle ones. So divisible by each of the integers 1 through 7 inclusive. So what it's saying is if it's divisible by each of those, it needs to have each of these numbers as one of its factors. Your first instinct may have been to multiply 1 times 2 times 3 times 4 times 5 times 6 times 7, which is an unhappiness-inducing number. It turns out to be this answer down here. 1 times 2 times 3 times 4 times 5 times 6 times 7. And that's not the right answer. While it is true that this number, while 5040 does in fact have each of these integers as its factors, it is not the lowest positive integer divisible by each of those numbers. Why is that? That is because in our numbers 1 through 7, there's some repeats and some combinations. The biggest and most obvious one probably is that the number 6 is actually the same as 2 times 3. Any number that has 2 and 3 as factors will automatically have 6 as a factor. So we don't need to multiply by 6 a second time because it's already got, if we've already multiplied by 2 and 3, we already have 6 as a factor. So we don't need to have another 6. So 5040 was clearly too big. And I didn't actually do the separate math on this one, but it wouldn't surprise me if one of these numbers is this whole set without 6 in it. However, we're not done with the tricky traps. The other one here is that if you have 4 as a factor of a number, you already have 2, because 4 is 2 times 2. Now, it is important that we use 4 rather than 2 as the factor of our final number, because we need 2 2's in a number in order for it to be divisible by 4. For example, the number 6 has as its factors 1, 2, 3, and 6. Just because it has the number 2 as one of its factors does not mean it has the number 4 as one of its factors. But if we take the number 12, for example, its factors are 1, 2, 3, 4, 6, and 12. So even though it has 2, every number that has 4 as a factor has 2 as a factor, but not every number that has 2 as a factor has 4 as a factor. So of the 2 and 4, the one that we need to keep is the one that has 2 2's in it, not 1. We get rid of 2 also. So now we're simply left with 1 times 3 times 5, times 4, times 5 times 7. So 3 prime numbers, 1 kind of doesn't really matter. So yeah, from there, that whole number equals 420, the smallest number on the list. So you can see then that the trap answer choice E had you multiplying everything, and then these other ones in between have you eliminating some things for some reasons, but it's actually the smallest of them because we can eliminate 2 of the numbers in the numbers 1 through 7 as factors. Choice A is correct. Number 37, still on page 157. I apologize for not putting the zeros in front of the decimal point. I never write it like that normally, and it's nice that the GMAT does, and I will try to write the answer choices as they have them, but occasionally I will forget, as I did just now. So 1 over the quantity 0.75 minus 1 equals something. Dun dun dun, what could it be? So one of the first things that we should recognize immediately is that 0.75 is a number less than 1. It's not a full number 1, yet So this number, which is a number less than 1, minus a number that is 1, is going to result in a negative number in the denominator. And since we have a positive number in the numerator, the final number will be negative, because a negative over a negative is the same thing as a positive. It's only when either the numerator or the denominator is negative and not the other one, that's when you end up with a negative number, which automatically allows us to eliminate these guys here, choices C, D, and E, because they're all positive numbers. So we've already improved our odds of guessing just by seeing that one thing. We've improved our odds of guessing down to, we have a 50% chance of getting this question right because we're awesome. The next step, of course, is to actually do the math. Usually on the GMAT, not always, but usually on the GMAT, something like this, it's easier to convert the decimal into a fraction. 0.75 is the same thing as 3/4. You should be familiar with some basic decimal to fraction conversions. There's going to be times when you need to go either way. It is pretty critical to success, to an awesome score. So this is the same thing as 3/4 minus 1, which is the same thing as 3/4 minus 4/4. Remember, any number over itself is the same thing as 1. So then we end up with 1 over negative 1/4. Remember, when you're dividing fractions, 1 divided by negative 1/4. It's the same thing as 1 times the or you invert the fraction and multiply it at the same time. It's the same thing as 1 times negative 4 equals, unsurprisingly, negative 4 itself, which is answer choice A. So with some careful attention to the properties of numbers and how fractions work, we eliminated a bunch of answer choices, and then beyond that, we, with some fairly straightforward arithmetic, and this, if this, I don't want to scare anybody, but this type of math here is something you need to be very comfortable with on the GMAT. If this was a stretch for you, definitely review your use of fractions and arithmetic and number properties. You will not regret it at all. It will make a huge difference in your score. How huge a difference, of course, does depend on how many of those questions you actually get on the test, but it's a big difference. Fractions are your buddies on the GMAT. Number 39, last one on page 157. Okay, we have some coordinates as our answer choices. Look at that, I remembered to put the 0 in front of the decimal. That makes me awesome for today. In the figure above, the point on segment PQ that is twice as far from P as from Q is what? I'm going to draw that guy. Hopefully. I want to redo that line. I did not like the way that turned out. Okay. So we have 1, 2, 1, 2, 3. So this isn't to scale because I am not a machine that can draw things that well, but the line passes through here, 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 and here. And pretend that that's straight. So we have P down here at negative 1. We have Q up here at 3 and 2. So we can tell basically that the line passes through, this is actually, 0, comma, negative 1. This is the point 1, or 0, 1. No, 1, 0. I do know how to do this. This is 2, 1, 3, 2. So the line has a slope of 1. For every 1 it goes over, it goes up 1. Fairly straightforward. we also know that the distance from P to Q is 3 units because it goes from 0 here for the x-coordinate to 3 here. So in some ways, it's divisible into 3 parts. The distance from 0 to 1, the distance from 1 to 2, and the distance from 2 to 3. And again, since it has a consistent slope, we don't need to use the distance formula or anything like that. So the question is, the point on segment PQ that is twice as far from P as from Q. So if P is at 0 and Q is at 3, the point that is twice as far from P as from Q is the point that's 2/3 of the way from one to the other. 2/3 is twice as much as 1/3. So the point that is 2/3 of the way is the one that's at point 2 on the x-coordinate, and that we already established was the point 2, 1, which is answer choice B. Note a couple of these other trap answers. Choice A, 3, 1 is over here. I should put these in a different color because it gives me an excuse to use different colors. So this is answer choice A. Choice A isn't even on PQ. Answer choice B, 2, -1 is down here, or choice C, sorry. Choice C is also not on PQ. Choice D, 1.5 and 0.5 is here. It is on PQ, but it's this is actually probably the midpoint. This is the midpoint of the line rather than the 2/3 of the way from P to Q. So, this is the answer to a different question. Another type of trap. And then 1, 0 is on the line, but this is the one that's 2/3 of the way from Q. So it's the right answer in the opposite direction. So not choice A, not choice C, not choice D, not choice E, but choice B makes us happy. Okay, on to the next page, where this time for real I need to eliminate my page number on the screen. Okay, page 158, question number 40. And then we have n plus 1, we have n plus 2, we have 2n plus 1, and n squared. So if n is an integer, which of the following must be even? So n is an integer. We need an even number. So this one is straightforward in its testing of our ability to recognize number properties. So n is an integer. We're going to be doing various things to it. We can see from the answer choices here that we're doing various things. We need to see which of these guarantees that the number we get is going to be even. So if n is an integer and we add 1 to it, is that guaranteed to be even? So if n starts out even, if we add 1 to it, it's going to become odd. If it starts out odd, it's going to become even. So because this is almost like a mini data sufficiency question, when the answer is sometimes yes, sometimes no, it can't be the right answer because we need the answer that must be true in every case. Choice B is going to work the same way, except the opposite way, of course. Even plus odd. So if it starts off as an even number and we add an even number to it, it stays even. Isn't that great? But if it starts off odd and we add 2 to it, it just skips the next even number and goes on to the next odd number, which is not what we're after. So it's not choice A, it's not choice B. If we multiply n times 2 and n is an integer, 2 times any number is automatically even. No matter what. because the number that you end up with is divisible by 2, which is your definition of an even number. So in this case, choice C is clearly our correct answer, but let's just cover the other answers just to make sure we know why they're wrong. Choice D, 2n plus 1, even though we get an automatic even number, adding 1 just does the same thing that this is. It gives us an even number to start with and turns it into an odd number. That can't be it. And the squared works the same way. If you start off with an even number, and you square it, it stays even. If you start off with an odd number, just pick one in your head, like 3. You square it, it stays odd. So it's not choice E. Choice C is our correct answer. It automatically always gives us an even number. And we get this one right because we're awesome. So question number 41. So let's see. We have -7. We have -4. We have -3, 1, and 6. So if 4 is one solution of the equation x squared plus 3x plus k equals 10, where k is a constant, what is the other solution? Let's get that one down. We have x squared, no, don't do this, plus 3x plus k equals 10. So we have 2 variables and only one equation. So that's a problem for us, and we're not going to be able to get very far unless we can get this down to one variable with our one equation. However, we do find out that 4 is one solution to this. So basically, we can plug the value 4 in for x and solve for k in that case. So that ends up being 4 squared plus 3 times 4 plus our mystery k equals 10. 4 times 4 is 16. 3 times 4 is 12 plus k equals 10. So then we have 28 plus k equals 10, and k must equal -18 because we subtract 28 from both sides. So now that we have k, we can actually plug k back into our original equation and solve for the other value of x, because remember, a quadratic equation is likely to have 2 solutions. So x squared plus 3x minus 18 equals 10. Now remember, in order to do any foiling, or in this case reverse foiling, we need to have the whole equation equal to 0. So we're going to have to subtract 10 from both sides. X squared plus 3x minus 28 equals 0. So remember, when you have FOIL, which stands for first, outer, inner, last, for when you have 2 binomial expressions like, x plus y times x minus y, you're multiplying times the first terms, the outer terms, the inner terms, and then the last terms. And then when you reverse it, you're looking for 2 numbers that when multiplied together give you -28, and when added together give you +3. So we have x, and when you have a negative final one, you're going to have x plus something times x minus something equals 0, because the positive times the negative is going to give you a negative final answer. We also know that the larger number needs to be the positive number, because when added together, it stays positive. It gives us +3. So the factors of 28 are things like 7 and 4 and 28 and 1. In this case, 7 and 4 give us the -28, and also the difference between 7 and 4 is 3. So we end up with x plus 7 and x minus 4. as our 2. We already knew that 4 was one of the answers, so the other answer then, remember, x plus 7 has to equal 0, so x itself equals -7 as our other solution, which is handily answer choice A. I think answer choice B here is meant to catch you if you weren't clear on how to reverse FOIL something. You might solve for this part down here and say, oh, x is -4, and choose this. Or you may have just figured, oh, well, if x equals 4, the other one must be -4 if you're in a hurry. Anyway, choice A is the correct answer. Okay, number 42. And then we have -22, -2, 2, 7, and 22. So if this thing, it looks sort of like a matrix. It doesn't matter if you're familiar with matrices because the GMAT will occasionally give you this is kind of a symbol question, where they'll give you some operation using some lines and symbols and things that are unfamiliar to you that then is defined in the course of the question. So this operation, which is, A, C, B, D, whatever that is, that operation is defined as AD minus BC for all numbers A, B, C, and D. So really, you almost have to ignore what the symbols mean, even if they look like something you're familiar with. Keep in mind they can do things like use a star or an asterisk, and those look kind of like multiplication, especially the asterisk, because you use the asterisk for multiplication in on a computer, but don't let your outside knowledge get in the way. Just do whatever the operation, whatever the defined operation is. So then we're given some actual numbers here. So then this thing, 3, -2, 5, and 4, we need to do that same thing. So A times D is these two numbers, 3 times 4. And we're supposed to subtract B times C, which are these two numbers, minus 5 times -2. So that's the same thing as 12 minus -10, which is, remember, when you subtract a negative, it's the same thing as a positive. It's 12 plus 10, and that equals 22. Our friendly neighborhood answer choice E. Our trap answers here, of course, they all look like, with the exception of this guy here, I have no idea where choice D comes from. I don't know where you're going to get 7 out of that. But all these other ones are misunderstandings about this stuff here. Because 12 minus 10, as opposed to 12 minus -10, gives you, so this is 12 minus 10. This one is -12 plus 10, so someone confused their signs. Again, if someone confused their signs, this is -12 minus 10. So, watch your signs in cases like, well, always. There are no cases where you should not be watching your signs. But in ones like this, where you have two answers that are mirror images of each other, like choices A and E, it's extra important because if you get it wrong, if you get the sign wrong, you will get the problem wrong. Choice E, correct answer. Okay, number 43. Interesting answers. 1/2 and 3/4. 1, 1, and 1 and 1/4, 1 and 1/4, and 1 and 1/2, and then 1 and 1/2, and 2. Okay, so the sum 7/8 plus 1/9 is between. 7/8 plus 1/9. Between's an important word here. It's an important word on the GMAT in general. So between, unless it says between x and y inclusive, you cannot include the two n's in the statement. So whatever the answer is, out of our A, B, C, D, E, this sum needs to be less than the big number and larger than the small number. Now, obviously, eighths and ninths are not part of this equation at all. We have everything in either whole numbers or halves and quarters. So eighths and ninths, eighths might get us somewhere, but ninths definitely don't. So it calls for a little estimation on our part. Let's tackle the easy guy first. 1/9. 1/9 is almost the same thing as 1/8. It's only 1 in the denominator off. Keep in mind that 7/8 plus 1/8 would equal 1. 1/9 is a little bit smaller than 1/8. So 7/8 plus 1/9 would be a little less than 1. If it's a little less than 1, any of these answer choices that have the boundary larger than 1 cannot be right. So we can say boo to you, choices C, D, and E. Our only remaining choices then are the ones that end with 3/4 or with 1. Let's tackle that first number then to see which of the other boundaries we can eliminate, because it's got to be one of either A and B. 7/8. So we're left with half and halves and quarters in the other ones. In choice A, in terms of eighths, it would be between 4/8 and 6/8. Choice B would be between 6/8 and 8/8. So of these, 7/8 is actually a little bit too big for choice A. 6/8 is just a little bit further outside the range than 7/8. So just as 1 is closest to this part of the equation, 3/4 is closest to this part of the equation, the 7/8. So these two things together make choice B our correct answer. Very important to be able to estimate some of these fractions, see what other things are close to. Okay, on to number 44. B is 3/2, C is 2/3, D is 2/5, E is 0. So if x equals 1 minus 3t and y equals 2t minus 1, then for what value of t does x equal y? So we're looking for, just to restate that another way, we're looking for the value of t where the two are equal. The way to set this up, of course, then, where t is the same for x and y when they're equal, is basically to set the two equations equal to each other. So x equals y. That's where we're trying to find the number for t. So we can just use those equations, substituting in the other things we got. 1 minus 3t, that's the value we're given for x. 2t minus 1 is the value we're given for y. We need to get all the t's on the one side and all the constants on the other. So we add 5t to both sides, or add 3t to both sides. We get 1 equals 5t minus 1. And then we add 1 to both sides. We get 5t equals 2. And then divide both sides by 5. T equals 2/5. Answer choice D. So really the difficulty in this one is realizing that if you're trying to find the value for t where the two are equal, that you should just set them as equal. So this is the hard part, the thinking part of this one. Once you're in it, then it's just a straightforward algebra problem, and you can take it from there. Obviously, these two answer choices are based on someone just looking at the coefficients on the expressions with the variable, a 3 and a 2, and so these would be true if it were 3t minus 1, and I don't know, the one, since the ones are the same, someone might look at this and think, oh, these coefficients, 2 times 3 halves versus, this would be picking different values for t basically. And then of course choice A is the inverse, so that's one type of trap. Should write that a little bit darker. These are other types of traps for those who are looking to do a shortcut without doing the math. Choice E, if it were 3t equals 2t or something like that, then 0 would be fine, but since we're subtracting it from 1 on the one side and subtracting 1 from it on the other side, 0 doesn't work either. So choice D, the correct answer for number 44. Number 45. We have 6/5, 7/6, 6/7, 5/6, and 0. So 1 minus the quantity 1/2 minus 2/3 equals something. Okay, so we have 1/2 minus 2/3. That's in parentheses, and we're subtracting that from 1. So this gives us something. Now, it's important to remember here your order of operations, even though in this particular case it's not quite as important. Parentheses, and this is the order that you should do things in when you are presented with multiple types of operations in an arithmetic expression. You have parentheses, exponents, multiplication, division, addition, and subtraction in that order. So in this case, we should do the parentheses first. You can't just subtract fractions from each other this way. You can't just subtract and get 1 minus 2 over 2 minus 3. It's not the same thing. You actually need to have a common denominator, as you probably remember. So the common multiple of 2 and 3 is 6. So we need to convert them into sixths. We'll probably be doing ourselves a favor by converting the whole thing into sixths. So 1 is the same as 6/6. 1/2 is the same as 3/6, and 2/3 is the same as 4/6. 6/5 is least easy to read fraction over the internet. Okay, so 3/6 minus 4/6 equals negative 1/6. And 6/6 minus that 1/6. Subtracting a negative number is the same thing as adding a positive number. So 6/6 plus, I could just say 6/6. I guess that would make my life easier. But I'm committed to ordinal numbers. Anyway, so it's the same thing as adding a positive number. So that's 6 plus 1 equals 7/6, which is our choice B. Choice C, I suppose, is meant to attract people who somehow confuse common denominators. because there's really no other way that you would end up with sevenths as the denominator. Choice A, you would have to reverse it and then somehow invert it. Choice E, I guess, is just an estimate, and then 5/6 is if you take subtracting a negative as just subtraction. So this is probably the biggest trap answer here, not converting from subtracting a negative to a positive. All the others involve larger errors in computation. On to number 46. Okay. So 0.001, 0.01, 0.09, 0.9, and 1.0. So this one, it's an unusual one. We have the quantity 3/10 raised to the 5th power divided by that same quantity 3/10 to the 3rd power. A few things to remember about exponents. Remember that just as x to the a, when you have things with the same base, times x to the b, this is the same thing as x to the a plus b. And so just as when you are multiplying exponents of the same base times each other, you add them. When you have x to the a divided by x to the b, that's the same thing as x to the a minus b. You're subtracting the exponents from each other when you divide one exponent of the same base. That's why this has an x in it. It's very important. It doesn't work if it's x and y. You need to be the same base. But when you're dividing exponents of the same base by each other, it's the same thing as subtracting those exponents. So this is the same thing as 3/10 to the 5 minus 3, which is the same thing as 0.3 squared. So 3 times 3 is going to give us something that has a 9 in it. We can cross off these 3 answer choices. The other thing to remember, if you aren't comfortable doing this sort of thing in your head, is that you keep when you multiply decimals times each other, you keep all the decimal places. So the fact that 0.3 times 0.3, it's going to give us something with 2 decimal places because we had one from this multiplication and one from this. So it's actually going to be the 0.09, which is choice C, the correct answer. Choice D here would be if we took 0.3 and multiplied it times 3, which is contrary to my understanding of how you square things, but that's what makes this one the trap. It's not a very sneaky one, but it would still catch people nonetheless. I probably shouldn't have put a square around that because that makes it look like a correct answer. Let's cross it off like that. So, choice C, 0.09. On to number 47. Okay, 45.5%, 46.5%, 48.0%, 49.5%, 51.0%. The proximity of these numbers to each other suggests that we are going to have to do some relatively precise calculations. The further the numbers are apart, the more likely it is when you get to the problem that you might actually be able to stop partway through and just by the basis of what you figured out so far, eliminate some or all of the answer choices. Since these are all pretty close together, we are going to have to do some math, whatever this ends up being. We haven't even looked at the problem yet. We already know that. Excuse me, already know that. So, in a horticultural experiment, 200 seeds were planted in plot 1 and 300 were planted in plot 2. If 57% of the seeds in plot 1 germinated and 42% of the seeds in plot 2 germinated, what percent of the total number of planted seeds germinated? So plot 1 has 200 in it, plot 2 has 300 in it. And we know that it was 57% of these guys and 42% of these guys. One of the ways you can cheat, if this isn't obvious, I'm going to mention it to you. It's not really cheating, but it makes the math a little bit easier. When you look at when you're given percents of numbers that come out to be even hundreds, you can decide, well, 57% of 100 is 57. That's the definition of a percent. So if 57% of 100 is 57, you would just double that for 57% of 200. So this is just 2 times 57. Which gives us 114 germinated seeds. We can do the same thing with this one. 42% of 100 is 42, so 42% of 300 would be 3 times 42, which equals 126. So the total number of germinated seeds, because that's what we're after here, we're after the what percent of the total number of planted seeds germinated. Our total germinated number ends up being 240, and that is then represented as a fraction of the total. So 240 germinated out of 500 planted. We need to simplify our fraction, get rid of the zeros first. We get 24 out of 50. Can divide the numerator and the denominator by 2. We get 12 out of 25, and from there we actually do have to do the math. If you're the sort of person who can look at that and figure it out, keep in mind that 12 25ths, if you were to multiply times 4 over 4, you would get 48 over 100. So you could convert the 25ths back to 100. I guess you could have done that here too. Guess I was just over-eager to reduce the fraction. Anyway, at any point, if you see a way to get it back up to a percent quickly, you can. If you didn't see that, that's fine. If you do the division, you very quickly realize that 12 divided by 25 ends up being 0.48, arriving at the exact same answer no matter how you get there, of 48%. The 48% of the seeds germinated between the two plots. Right. So, choice C is the correct one. I think we have time to do question number 48. Okay, we have 45. Oh, dear, this is on page 159. I'm sorry. So caught up in getting one more done. 67.5, 112.5, and 135. So in the figure above, if line or segment AB is parallel to segment CE, and CE equals DE and Y equals 45, then X equals what? So we're given a diagram that looks like this. And yeah, that's more or less right. A, B, C, E, and D. One of the things we know, though, that might make our life easier is that CE and DE are the same length. So maybe we should draw one where they are the same length. CE and DE. Let's see if I can get that to come out right. That's probably about right. And these guys are parallel. So it probably looks something more like that. The figure was not drawn to scale on purpose to mislead you. but perhaps this will make things clearer. C, E, and D, and then we have Y there and X there. Okay, so now it's about what we can figure out. I'm going to change the color scheme to reflect that. AB is parallel to CE. So the key here, when AB and CE are parallel, that means that what do we call them? I'm blanking out. Basically, when they're parallel, this angle here, this x is going to equal this x here, because the lines are transverse angles. Is that the word? Oh my gosh, this is terrible. Well, just pretend I remembered what the actual word is, and the diagram clarifies it. So this angle x is the same as this angle x, the two that are in red. So we can actually fill this in our scale diagram as well. We also know that CE equals DE. So these two guys, I'll change the color again because why not? CE equals DE. So these two are the same, and that means that this is an isosceles triangle. Remember that isosceles triangles are triangles that have two sides that are the same length. The sides opposite the angles opposite the, so if this is side x and this is side x, the angles opposite those will have the same measure. So angle A opposite x and angle A opposite x, and then this one would be a different measure. So if the two blue sides have the same length, the angles opposite them are the same, which then means that this angle here is also x, because these are the two sides, or the two angles opposite the equal sides. Now we then have a triangle, and we know all three values for the angles of the triangle. We know that, so we know that x plus y is going to equal 180. There's 180 degrees in a triangle. We know then that 2x plus and y we are given as 45 equals 180. So 2x equals 135, and x therefore equals 67.5, which is what we were after. Answer choice C. So that is going to be a great place to stop. We will pick up where we left off next time. We're still going to be on page 159, and we're going to move on to question number 49. So that's where we'll start next time. My name's Jim Jacobson. You've been watching the Grockit OGTV program, one of the editions. This one's the GMAT one, where we go through the official guide to the test 12th edition, like it says at the bottom of the screen down here. This is the